ओके जी, अस्सलाम वालेकुम एवरीवन। कैन यू हियर मी जी? आवाज आ रही है सबको?
Yes, sir.
ओके। तो लेट्स स्टार्ट विद आ गए हैं बाकी सब लोग या?
Yes, sir.
ओके देन let's start with attendance. My view of things. So we have lecture number, I believe it's 14. ऐसा ही है?
Yes, sir.
Okay, roll number 1 is present.
Yes, sir.
Then 2,
Present, sir.
3,
Present, sir.
5,
Present, sir.
10,
Present, sir.
17, 17, Anam Afzal.
17 present, sir.
Okay. 18,
Yes, sir.
27,
Present, sir.
then we have 36,
Yes, sir. Present.
then we have 43,
Present, sir.
46, Irtaza Hussain present? No. Okay. 53,
Present, sir.
56, Aisha Tayyab, not present so far. 70,
Yes, sir.
80,
Present.
80,
Present, sir.
56.
hold on बच्चे, आखिर में 110, 110 is present. Muhammad Asad, no. 113,
Present, sir.
114,
Present, sir.
120, Abda Iqbal, present or not? No response. 124,
Sir, 120 present.
120, अच्छा चलें. 124, Noor Fatima, not present so far. 140, Iman Gul, not present. Now जो लेट आए हैं बताएं, hurry up.
Sir,
कौन आया?
56.
56. Okay. और कोई anyone else? कोई और आया है जिसकी मैंने नाम नहीं बोला या रोल नंबर नहीं बोला? Okay then, मेरा ख्याल है most of you are present except I believe 3 students. So let's start today's class. So this is lecture number 14 and we'll start chapter number 6, which is link layer and lens. This is the last chapter, in fact, which we are going to through this course. I hope you are doing, complex engineering problem project. You have started work on your project, so please follow the schedule so that it can be evaluated within due time. So link layer and lens. So this is how we will start. This is our goals of link layer and lens. Basically, we are going to understand the principles behind link layer services, and it includes error detection, correction, and sharing a broadcast channel. I hope now everyone knows what is broadcast. Broadcast means sending to everyone. And in this, we have a method, because in broadcast, there are additional complexities when we want to transfer a data or information or packet. So this is known as multiple access. Multiple users can communicate with each other in a broadcast medium. So there are additional complexities, and we call it as the multiple access. So we'll study multiple access algorithms in this chapter 2. Then we will talk about link layer addressing, and then local area LANs. Because local area LANs, Ethernet, VLANs, they have two layer jurisdiction, that is link layer and physical layer. Now you may be wondering that we have studied physics application layer, we have studied transport layer, we have studied network layer, right? And now we are going to study link layer. So where is physical layer? So physical layer does not have much functioning, except it provides the hardware interfaces to physical cable. So we will study a little bit about physical layer in this chapter. So therefore, this chapter will complete the concepts of all layers which are necessary to understand in first level of course of computer networks. So now, then we'll talk about data center networks. This is a new thing which is basically happening recently. So we'll also discuss this, and then we will be, completing the whole concept. Okay, how initiate instantization and implementation of various link layer technologies are being done in today's internet. So this is our roadmap. Roadmap means that this is a flow of topics which we are going to study in it, and we'll start from introduction, in fact, and then we'll be going to other topics in this chapter. So inshallah, we'll study the complete chapter, this chapter, in this course. So um, let's see. Let's start with introduction, and at the end, we will be going to complete the concept. Okay, if we start to go to access a web page, so what are the things happening all the way down to getting that page? So that is will be summarized in the this section, a day in the life of web request. So anyways, let's start with introduction. Now
Excuse
when
me,
we say G, please.
sir, please mark my attendance. Sir, I am 18E140.
बेटा जी, आप अटेंड लेक्चर से ज़्यादा अटेंडेंस को इम्पोर्टेंस देते हैं। आप मैसेज में लिख दें या ब्रेक हो तो उस वक्त बता दें। आपको पता है ऑटोमेटिकली जब आप ऑनलाइन होते हैं तो सिस्टम आपको रिकॉर्ड कर लेता है। अटेंडेंस इसलिए मैं मार्क करता हूँ कि मैं अटेंडेंस को आगे मैंने देना होता है, और उसके अंदर मैं अगर आपकी टाइमिंग नोट करके अटेंडेंस मार्क करना शुरू कर दूँ तो फिर इट इज़ अ क्वाइट अ हैसल फॉर मी। दैट्स व्हाई आई मार्क अटेंडेंस फिजिकली टू। सो प्लीज डोंट इंटरप्ट ड्यूरिंग द लेक्चर। जब आपसे कोई क्वेश्चन पूछा जाए या पॉज आए ब्रीफ, तो अपनी अटेंडेंस के बारे में उस वक्त बताया करें, राइट? तो प्लीज कीप दिस थिंग इन माइंड, क्योंकि बीच में सिर्फ अटेंडेंस के लिए आप रोकना लेक्चर को, इट डज नॉट लुक नाइस, राइट? So I will mark your attendance. You don't need to worry about it. Okay. But now I cannot go
Okay,
back to that Excel sheet and then find out your name and then put a P there. So please wait for a brief pause. So I'll mark your attendance. Okay. So link layer introduction. This is section 6.1, right? So look at the diagram on your right side. This is the same old diagram which we are studying from last 13 weeks. And it includes network edge and network core. So you know that link layer is present in everywhere. Either they are end systems, either they are routers, whatever it is, either they are data center networks, whatever you call. So then you can basically find out this link layer everywhere. Now what is the responsibility of then link layer? So link layer, before I talk about link layer, let's define node. Now here in this chapter, we will call either it is a router, either it is a smart device, either it is a laptop, either it is a desktop, either it is a server, or any device, we will call it as a node. We will consider it as a node. So link layer basically has a responsibility of transferring data, gram, from one node to physically adjacent node. Physically adjacent node over a link. Link means that physical link, right? It can be wired or wireless. I mean, so physically adjacent. Adjacent means directly connected. So this is a responsibility of a link layer that basically transfer datagrams from a node to next node, which is directly connected, which is adjacent to that node and connected through a link. So link normally, when we talk about link, people may think that it is a wired link, but it can also be a wireless link. So these are terminologies. So as I already told you that we will be calling host and routers as nodes in this chapter context. So these are nodes. G. We will call them as nodes. Then communication channels that connects adjacent nodes along communication paths, we will call them as links. So these are the terminologies which are very specific to this chapter. So the channel can be anything. Channel can be wired, channel can be wireless, and even if it is a wired, it can be a UTP, it can be a optical fiber, it can be any physical link. And wireless में तो obviously wired भी हो सकता है, radio channel हो सकता है, satellite link हो सकता है, तो microwave link हो सकता है, so any link. So this is something, it can be wired, it can be wireless, and it can be any lens. लोकल एरिया नेटवर्क के अंदर भी लिंक्स बनते हैं, कम्युनिकेशन पाथ्स बनते हैं, so we will call them as all as links. So in link layer 2, basically packet is a generic term. In network layer, the specific term क्या हमने use की थी, specific term network layer के अंदर we call it as datagram, right? So in this context, in layer 2, packet is known as, packet is a general term, right? Packet you can call it as in communication networks. So but in layer 2 context, we call this packet as a frame. This is something which I assume you already know about it, but because we are starting this chapter, so again we will stress this, focus this thing, that we will call the packet at layer 2 as frame. So you know that above link layer, which what is the link layer above link layer? What is the name of layer?
Network layer.
Network layer, right? So basically, so network layer generates datagrams, and that datagrams are given to link layer. So link layer will encapsulate that datagrams, and when it encaps in its payload field and plus headers, it is known as frame. This is what we call frame, right? G. So this is something which you have, so have a look on it, and if you have any question, you are welcome. Please go through these terminologies, and if you have any question, you can ask. So I'll give you 30 seconds, around 30 seconds for it. अब बताएं कौन लेट आया है? जी किसकी अटेंडेंस मार्क नहीं हुई? प्लीज पिक अप. No one? Someone was interrupting me and for attendance now. Where is she now? Am I audible to everyone, Ji?
Yes, sir.
So now this is the point. You turn on your systems and then I don't know. I don't know. I don't want to further comment on it. But now no one is speaking about her attendance. This is very sad. Okay.
सर उन्होंने लास्ट में लगवा दी थी.
सर एक्चुअली मेरा ना नेट का इशू है, मेरी क्लास बार बार ना डिस्कनेक्ट हो जाती है.
क्या रोल नंबर है आपका बेटा?
सर 18EE140.
Okay, 140. So I'm recording this lecture. So you can, also see the recording. You can later on, अगर आपको कोई disconnection का problem है, तो you can, do this. Okay.
ओके सर.
Okay, ji, let's come back. I think Noor Fatma is not here, despite the passage of 25 minutes of class. And Muhammad Said, no, sorry, This one, Muhammad Asad is not here, and then we have Irtaza is not here. So these three students are not here so far. Am I right?
Yes, sir.
ग्रैंडफादर फोर्थ हो गए तो इसलिए वो आज क्लास नहीं
Please
ले
speak loudly. I cannot hear you.
सर इर्तिज़ा के दादा अब्बू फोत हो गए थे तो इसलिए वो क्लास नहीं ले रहा है वो बता रहा था मुझे
Okay, okay. Sorry to hear this, but anyways, because he's physically not present, so okay, okay. I can understand this thing. Okay. So remaining two students are not here, and the names I have already Muhammad Asad and Abda Iqbal. Okay. So okay, I think enough time has been passed. So if you have any question, please go ahead. If you want to ask any question from this slide number 5, slide numbering is given on the bottom of the page. So you can see there that there is a, slide number 4, sorry, slide number 4, which we are talking. And if you don't have any question, then let's move to the next slide, which is slide number 5. Now, basically, as I told you that datagrams are generated at network layer, and basically they are given to link layer, and link layer basically has a frame, and that datagrams are encapsulated in frames payload field, and it adds its own header, and then it is transferred to link by link basis, and it has different protocols over different links, because there are various varieties of links. It can be a wired link, it can be a shared link, it can be a wireless link. We'll talk about it, but there are different variety of links, so different protocols exist for those different services. So each protocol provides a different service, and it may or may not provide a reliable. For example, it may or may not provide a reliable data transfer over a link. It is quite possible that some links are providing reliable data transfer, the same concepts which we have studied in chapter 3. It is quite possible that they are providing those reliability through that concepts, and it is quite possible that no reliability is provided. So in order to understand, working of various layers, that we are, sometimes we give analogies. So let's try to understand this link layer context with respect to analogy. So detailed story of analogy is given in the book in this first section. So you can read from here. But let's say that we are going to arrange a trip from Princeton to Louisiana. Now, probably you don't have idea, because it's a U.S. author. Origin is U.S. author. So Princeton is a city in U.S., and Louisiana is in Switzerland. So Lausanne is in Switzerland, right? So give this thing little bit of map. So limo, limo is kind of a taxi. So you can consider it as a taxi cab. So naturally, when you are trying to arrange a trip from Princeton to Lausanne, Lausanne is in Switzerland and Princeton is in USA, right? So let's say that you use a cab or limo. I'll call limo because this is the same thing which will be written in your book. So limo is a quite a big cab. So you use a cab or taxi from Princeton to JFK. JFK is a name of airport in New York, John F. Kennedy Airport, right? So this is the airport in New York. So what is going to happen in this trip? That limo is being used by a person to move from Princeton to airport JFK, and then after that, uh, moving from New York airport, that is JFK, to Geneva, aeroplane is used, right? Aeroplane is used to move from JFK to Geneva. And when a person reaches a tourist, let's call it as a tourist, when tourist reaches a Geneva, he takes a train from Geneva to Lausanne. So now look at this. There are, a complete trip, and that complete trip is basically moving from, Princeton to Lausanne, and that complete trip has three phase of transportation. and that tourist is taking, for example, Princeton to Lausanne is limo, and then aeroplane or plane is from JFK to Canada, and then train is Geneva to Lausanne. So in this context, the tourist which is moving from, which is taking that trip is no, we can analog it. Analogy is being taken as datagram. That a tourist is actually a datagram, and that transport link we can consider it as a communication link. For example, by road, this limo is a transport communication link, which is by road, right? And then plane by air is another type of communication link, and then train is another type of communication link. And the mode which you are using, for example, cab is a link layer protocol. Plane is another type of link layer protocol, and train is another type of link layer protocol. So, you are using three types of transportation modes, and you can make this these transportation mode analogy with link layer protocol. And this transport segment, train, road, air, can be considered as communication link, and tourist as a datagram. So this is something which you can say being done in link layer. And overall, your travel agent, which basically plans the whole journey for you, you can consider it as a routing algorithm. So I hope that this analogy will differentiates between working of transport layer, which is routing algorithm. Which is being used in transport. Sorry, network layer. Routing algorithm is used in network layer, and the other things transportation analogy, which is being done in link layer. So please have a look on it, and if you have any question, you can you can ask. So you must be clearly must be able to clearly differentiate between the working of network layer and link layer. So you must be understanding this. So this slides basically tries to explain to students that what is the difference between link layer working and network layer working. So please have a look on it, and if you have any question, you are welcome. I'll again give you some time for reading all of this and recapping the things, recalling the things, and so that you can ask a question if any.
Excuse me, sir.
Ji beta.
Sir, can you please mark my attendance? I joined late at 12:14.
What is your roll number, bete?
Sir, 124.
Okay. Okay, please now consider read these slides and okay, Ji. Okay. Is there any question? You can freely ask the question if you want. Okay. I assume that you have understood it. Let's move to the next slide. So now we'll talk about various services which are provided by link layer. So you can see a diagram here on the right side, which describes different kind of links. For example, at the top of the diagram, look at my this cursor movement. Can you see my cursor? Can you see my cursor?
Yes, sir.
So the top right top is basically a communication link, wired link, but it is shared between all various nodes. Shared medium. This red medium which is shared. We'll talk about its details later on, but this is a shared channel which is shared between various residences. Look at the mid diagram, right mid. This is a wireless channel, wireless link. Another right side, this is also wired link, but it is not shared, it is through a switch. And the bottom one is access point. So there are various types of links, as I already told you. And the first service which is provided in link layer is known as framing, that it frames the datagrams in encapsulates the datagram into frame, adding a header. And one new thing which is being done in link layer, which is not present in previous layer, is addition of trailer. Trailer is at the end of payload. Header is at the beginning of payload. In this case, payload is, what is payload in this case at link layer? कौन बताएगा what is payload?
Datagram.
Yeah, payload is datagram. So at the beginning of payload, there would be a header, and at the end of the payload, there would be a trailer. This is a new thing which is being done actually at link layer. Then channel access. I've described on the right side figure that there are a variety of channels, and if it is a shared medium, so there is a issue of channel access, that who will communicate with whom, because if multiple nodes start communicating with each other, their frames will collide with each other, and they will be corrupted. So therefore you need some kind of algorithm to access the channel if it is shared. In case of wireless, same scenario is there. So this is another service provided by link layer. Then MAC, medium access control. Now basically link layer is generally divided into two sub layers. So the main sub layer in it is known as MAC sub layer. The other is known as logical LLC, logical link control. So that basically hides the differences between these various kind of mediums from network layer, because network layer is not aware that what is going on in link layer, what type of medium is used in link layer. Network layer is not does not know anything about it. So LLC, that sub layer, basically hides that differences, but the main layer is known as MAC sub layer. So by virtue of this medium access control, we call the addressing mechanism at link layer as MAC addresses. MAC addresses, there are other name for it. They are also called as Ethernet address if Ethernet is used. That is also called as physical addresses, that are also called as link addresses, but more common name is MAC address. So MAC addresses in a frame headers. So same thing is there in case of MAC addresses, that there will be a source MAC address, there will be a destination MAC address, but that is different from IP address. That is different. So this is an additional address, like a port address which you have studied in transport layer, IP address at network layer. Now MAC address is at link layer. So this is something additional thing which is being done in link layer. This is something the services which are two services, main services which are provided, are known as framing and link access. Then there is a possibility of reliable delivery between adjacent nodes. We can provide a reliable delivery. How we provide this, we will not discuss in this chapter, because we have already studied the concepts of reliability delivery in chapter 3 in great detail. So the same concepts which will, the same algorithms, in fact, the same concepts will be used if reliability is provided between adjacent nodes. So basically, if your links are low error links, low bit error links, and like a optical fiber, it does not make a lot of errors. So then this reliability is seldom used. It's rarely used. But there are some mediums in which high error rate is there, like wireless links. Wireless links due to interference make a lot of errors. So there we provide a reliability. We provide a both link to link and end to end reliability. Link level reliability is provided by basically link layer, and end to end reliability is provided by which layer? Can anybody tell?
Transport layer.
Yeah, transport layer. So we need both of them. So think about the reason for it. We'll discuss reason later on, but think about it. Okay, why we need these both reliabilities at link layer as well as at end level. So there is a very logical answer for it, but we will not discuss here so far. Okay, ji. Before I move quickly to next slide. So again, I'm coming back to this slide number 6. So please read this, and if you have any question, you are welcome. Okay, जी, is it okay to everyone? किसी को कोई क्वेश्चन तो नहीं है?
No, sir.
Okay, if you don't have any question, let's move to the next slide. Slide number 7. Now we'll talk about further additional services. Flow control. I hope you know the definition of now flow control. This is also being provided by link layer. It can be provided by link layer, fast sender and slow receiver, adjacent, but that is between adjacent sending and receiving nodes, right? And then there is next is error detection, that errors may cause by attenuation, signal attenuation and noise. So we need to detect errors, and because detection does not involve correction. So how to correct in this scenario? We do retransmissions or drops frames. If error is detected, the frame is dropped and request is sent for retransmission, and then signal is recovered, that error is recovered by doing retransmission. So this is being basically done in error detection scenario, that whenever there is an error detected, then what happens, that frame is dropped and a single retransmission request is generated, and we recover from error in error detection scenario by doing retransmissions. Then another method which is known as error corrections. In error correction, we don't have retransmission. In fact, we basically correct the bit errors at destination. So receiver identifies and correct the bit errors without retransmission. Actually, in error detection, in a frame, you know there is an error, but you don't know the location of the bit which is in error, or bits which are in error. You don't know about the location. So what you do? You do retransmission to recover from error. But in error correction, you identify the bits which are in error. So once you identify the bits, so it's very easy to recover from it, because there are only two possibilities. Either it is a 1 or 0. So if you recover that these bits, 1 bits are in error, so you flip the bits, and automatically you recover that from error. So actual issue is to recover from to find out the bits in the frame which are in error, and then you correct it without retransmission. So obviously retransmission is not required in case of error correction methodology. Then next service which is provided is known as half duplex and full duplex. You know about it. I will not go into the further detail about it. So these are some additional services, more services which are provided by link layer. Please again go through this quickly. I'll give you some 30 seconds say. and then we'll continue. Okay, Ji, is it okay to everyone? So if it's okay, let's move to the next slide. And this slide discuss that where link layer is implemented. But before I talk about the location of link layer implementation, let's talk about other layers. So what do you think where transport layer and network layer are implemented? Can anyone tell? G?
सर एप्लीकेशन लेयर तो मेमोरी पे होगी ना यानी कि
एप्लीकेशन लेयर तो बेसिकली इज ब्राउजर जो है वो आपका एप्लीकेशन लेयर की इम्प्लीमेंटेशन है। ये गूगल क्रोम जो है एप्लीकेशन लेयर की इम्प्लीमेंटेशन है और उसका पार्ट ऑपरेटिंग सिस्टम में होता है। ऑपरेटिंग सिस्टम, आंसर इज ऑपरेटिंग सिस्टम। ईच ऑपरेटिंग सिस्टम हैज ट्रांसपोर्ट लेयर एंड नेटवर्क लेयर इम्प्लीमेंटेशन। आप ऑपरेटिंग सिस्टम में जाते हैं, उनकी प्रॉपर्टीज में, वहां से आप आईपी एड्रेस भी चेंज कर सकते हैं इफ यू वांट, डीएचसीपी की सेटिंग्स, ये वो, ट्रांसपोर्ट लेयर। सो ऑपरेटिंग सिस्टम सॉफ्टवेयर। नाउ व्हेन वी टॉक अबाउट लिंक लेयर इज अ मिक्सचर ऑफ हार्डवेयर एंड सॉफ्टवेयर and firmware. So link layer is present in every host, each and every host, either it is a router, either it is an end system, whatever it is. And this is implemented in a device on it, basically, which we call it as network interface card, NIC. We call it as network interface card or NIC. And this NIC can look like this, which you are seeing here. So in a computer system, this is a NIC, this is a wireless NIC, it has an antenna, and this is for desktops, and this is a wired NIC. You see a small port here where you insert a cable along with connector. But in, for example, in your mobile phones you also have antenna, but that antenna is hidden. That antenna is not, you don't see antenna in a mobile phone. Same is the case for laptops. So laptops also has wireless NIC cards, but you don't see antenna. Antenna is hidden inside it. And these days, initially when desktop systems came in, so we normally had a PCI card, and sorry, NIC card, which is inserted on PCI slot. But these days they are embedded as a chip, right? So they implement these NIC cards, implement Ethernet, and it can be a Wi-Fi card or chip. And what is the implementation inside it? They implement link layer and physical layer, link layer and physical layer. So look at the internal of it. So internally, there is a CPU in a system, there is a memory. So this is a PCI slot, BCI slot, and you insert a network interface card here. So that can be also built in. But initially some has slots, and you can also put a slot here. And it has two parts, controller and physical layer. So we'll talk about it more detail in next slide. But look at this. So this is a combination of hardware, software, and firmware. So please have a look on it. And if you have any question, you are welcome. Is it okay to everyone, Ji? If it's okay to everyone, let's proceed to the next slide. So look at this before we moving to next slide. So CPU operating system, application layer, transport layer, network layer, and part of link layer. So as I told you earlier, that is a mixture of software and hardware. So hardware is implemented in NIC, and firmware is also implemented in NIC. What is firmware? A software program embedded, a fixed software program embedded in a some memory, which cannot be changed generally. So this is how it looks like. Is it okay to everyone, Ji? Okay. Now let's come inside to it. Okay, how interfaces are communicate. That communication between how interfacing is done. So this is systems, two systems. One you can consider it as host A or B or X or Y, and they are communicating, through this blue line is a, you can consider it as a physical link, wired or wireless link. So how this is being done, datagram is generated from network layer, and that datagram is given to link layer. Link layer adds its own header, sender side, let's say left side is your sender side, and sender side adds its own header, and we then call it as a datagram. Obviously it adds also a trailer in it. Trailer is not shown here, but it adds a trailer in it also, and add error checking bits, reliable data transfer, and flow control, etc. information, and then it transmits it to the other side, receiver side. Now, receiver side is your right side. When receiver side gets this frame, then it looks for errors, and if there is a reliable data transfer is implemented, it will check for its reliability, flow control, etc. And then after doing all these processes, it extracts the datagram at the receiver side and passes it to the upper layer, which is network layer. In this way, these interface will communicate. Have a look on it, and if you have any question, you can ask. So we are doing 6.1, which is introduction to link layer. So this is a section 6.1, which is introduction to link layer. And if you don't have any questions, then this completes 6.1. This completes 6.1. Let's move to 6.2. So in your book, 6.2 title is Error Detection and Correction Techniques. This is the title of exact title of this section in your book, but here in slides it is abbreviated as Error Detection Correction. So in book, Error Detection and Correction Techniques. So this is 6.2. So let's now start 6.2. So slide number 11, because it talks about error detection and correction. So let's start with error detection. That what kind of mechanism is being used as error detection in link layer. Recall that you have studied one error detection method at transport layer. What was the name of it? किसी को याद है कि उसका नाम क्या था? जी, what was the name of it? ट्रांसपोर्ट लेयर पे एरर डिटेक्शन का मेथड क्या था?
Sir, checksum.
Right, good. Checksum. But here error detection method is different from checksum. So please concentrate on it, that how it is different. So basically, we have an error prone link, means that link makes error. And in order to understand this, we will define certain terms. So first term is EDC. EDC are actually extra bits which are not part of data, and we add them for error detection and correction bit purposes. So that's why we call them as redundant bits or redundancy, because they are not official part of data. They are added into the link layer frame in a specific field, so too for detection of error and its correction. So that is known as EDC. We are calling them those bits as EDC, error detection and correction bits. And then we are defining next term, which is a D, data. It can, in this case, it can be a datagram, it can be any data, but in this case, a datagram, the data which is need to be protected by error checking. And it includes header fields, क्योंकि डाटाग्राम तो नेटवर्क लेयर से आएगी, तो इसके in addition to datagram there are other fields at frame level. So data to be protected means that it includes datagram as well as header fields. It may include header fields, it depends upon the implementation, but it may include header fields. So these are the two terms which you need to keep in your minds. EDC are error detection and correction bits which are additionally added, which are not part of data. We sometimes call them as redundant bits, or redundancy is being added. And D, a data which is to be protected. It can be a datagram, and it may include header fields. So this is a diagram. So if you look at this diagram, look at my cursor. So datagram is coming from network layer, and actually at physical, it will be given to link layer. There is an error prone link, and this is being done. Look at this. D is datagram. It may include header fields. So D जब हम कह रहे हैं इसमें datagram भी और header fields भी हो सकती हैं. D data bits. Let's call it as an, collectively we are denoting it by capital D. ठीक है, so this is data to be protected by error checking, and these are EDC bits. ED bits are additional redundant bits which are not part of data, but which are being used as as error detection and correction bits, right? So this is being done in link layer. Link layer adds EDC. So obviously it does not add EDC randomly. There is a certain method, but this slide gives you an overview of error detection. So this is something which is being done. Datagram or data comes in, and that the EDC bits are appended. Added means appended with data bits as trailer. Generally, this is trailer at the end of the payload. So EDC bits are added, and then at the sender side, and there is a specific method for adding EDC bits. We'll talk about that method later on, but these bits are added at the sender side, and after doing this, we basically transmit it through a error prone link. We transmit it through a error prone link, and on the receiver side, let's say we call them as D dash and EDC dash are received. At the receiver side, D dash and EDC dash bits are received. So these bits are checked using these redundant bits. Basically, D dash is checked that all bits are in D dash are okay or not, are free from error or not. So there are two possibilities. So these EDC dash bits are used to find out whether they are D dash is in error or not. How it is used, we'll later on we'll discuss this. But again, it is overview. So D dash is checked whether all bits in D dash are in OK or not. If they are not OK, then it means error is detected. If no, means that error is detected, and otherwise no error. And if there is no error, it will be given to upper layer, which is a network layer, and datagram is extracted and it is given to upper layer. And if it is no, it means error is detected. So before we move further, have a look on it. Big view, overview, okay, how error detection at link layer is done. If you have any question, you are welcome.
सर ये बिट एरर फोन लिंक से क्या मतलब है?
Bit error prone link, ये फिजिकल लिंक है, ये फिजिकल लिंक है जो एरर प्रोड्यूस करता है। एरर प्रोन का मतलब यही है कि बिट लेवल पे ये एरर जनरेट करता है ड्यू टू नॉइज। ये एरर फ्री लिंक नहीं है, इसका मतलब ये है। क्योंकि अगर एरर ये जनरेट ही ना करे तो फिर हमें तो ये करने की जरूरत ही नहीं है ना। इफ इट डज नॉट प्रोड्यूस एनी एरर। जी प्लीज, कैन यू रिपीट?
यस सर, मैंने ये बोला कि फिर डिटेक्शन का फायदा है।
ओके Okay, ji, so this gives you an overview that how error is detected. EDC bits are added at the sender side through some method, which we'll discuss later, and then the data bits, DE bits, plus EDC, plus means appended EDC is transmitted on an error prone link, and the receiver basically check whether D dash is in error or not. If no error, then D dash is extracted and given to D dash is equal to D in fact, and is given to data network layer. If no, then we say that error is detected. And in case of detected error, let me tell you, retransmissions are done. So you know error detection के अंदर क्या होता है कि basically you don't know the location of bits which are in error, and basically retransmission request is sent by receiver to sender, because noise is random in nature and we assume that next time there will be no noise, and even if the next time there is noise, then again retransmission request is sent. Now one more thing which you need to understand is that no method is 100% perfect. So this error detection method is also not 100% reliable. Recall checksum में भी हमने कहा था कि अगर कुछ bits same bits flip हो जाएं तो आपका checksum same आएगा, तो वो भी reliable नहीं था 100%. Same is the case that error detection method is also not 100% reliable. Protocol may miss some errors, but it's very rare. It very rare. Now, if you want to increase the accuracy, error detection accuracy, then solution to it is to use larger EDC fields. ये EDC जो redundant bits आप ऐड कर रहे हैं, so accuracy को अगर आप बढ़ाना चाहते हैं तो use a larger EDC fields. So larger EDC field means more bits in EDC fields will yield better detection and correction. Will yield better detection and correction. But downside of it is more computing complexity. More computations are required. So this is something which you need to understand. Is it okay to everyone, Ji? Is it fine? Am I audible to everyone, Ji?
Yes, sir.
Okay, I'll assume that you have understood this. Please keep this big picture, this overview in your mind, because now we are going inside of it. The next slide will talk about further details about error detection. So, before we move to this error detection mechanism, there are various methods for error detection. So this is one thing, parity bit, the simple thing which you already have studied in logic design. So I'll not talk much about it, but single bit parity में आप क्या करते हैं कि you add a parity, and in this case even parity is used, means that you set the number of bits such that number of ones are even, right? So if number of ones in D data bits are already even, you put a 0, and if they are odd, then you put a 1 in it. This is known as single bit parity method. Now this single bit parity method is not very efficient. You know, this is not very efficient कि अगर दो bits flip हो जाएं तो तब भी वो even ही रहेगा. So in order to increase its accuracy, two-dimensional bit parity is also used. So two-dimensional bit parity method basically does what it does. It basically divides the data into various rows, and it takes a row parity as well as column parity. Look at this diagram that each row's parity is taken, that whether it is an even parity or odd parity does not matter. So additional bit is added for every row, and then column parity is taken. That additional bit is added for every column. So that's why we call it as two-dimensional bit parity. And it can detect and correct single bit errors. Again, single bit errors. So look at this example. So look at this row. Each row is what type of parity now we are using here in this case? In this example, कौन सी type of parity use हो रही है? Even use हो रही है, odd use हो रही है? तो बता सकते हैं?
Even.
Yes, even parity is used. Look at this first row में three number of ones हैं, odd हैं, तो even parity use हो रही है. Second row में zero है because four ones are already there, and then third row में three ones थे तो one आ गया. फिर हमने column parity ली. Column parity में देखिए कौन सी use हो रही है parity. कॉलम पैरिटी में
Odd.
ये इवन ही यूजर ही यहाँ पे एरर है, ये यहाँ पे जीरो होना चाहिए था, पहले में जीरो होना चाहिए था. देखिए वन वन है तो जीरो, वन 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 इवन वन, सो वन 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 एंड देन वन वन, और ये वन वन जीरो, तो ये पहले कॉलम में एरर है, ये इसमें गलती है, ठीक है. तो कॉलम में भी एरर बिट इवन पैरिटी ही यूज हो रही है, तो पहले कॉलम में क्या गलती है, क्या होना चाहिए था आखिर में? पहले कॉलम में मिस्टेक है, प्लीज करेक्ट दिस मिस्टेक.
सर उसमें 111 होना चाहिए था ना पहले कॉलम में.
पहले कॉलम में आखिर में इवन पैरिटी के लिए क्या होना चाहिए था? जीरो नहीं होना चाहिए था, ऑलरेडी इसके वन है ना, जीरो होना चाहिए था ना.
Yes.
क्योंकि आपने इवन पैरिटी ली है ना. ओके, राइट साइड देखें, राइट साइड को, लेट्स मूव टू द राइट साइड. So if you know there are no errors, you will get the same thing. No errors means you will get the same thing. What is being transmitted, same is being received, no errors. But in case of errors, look at this. Here actually we have got this at the this thing, and let's say that यहाँ पे अगर आप देखें सेकंड रो में, तो ये दूसरा जो वन, दूसरी जो बिट थी वो सेकंड रो में वन थी. अब एरर होने की वजह से ये बिट जो है वन से क्या हो गई है, जीरो हो गई है. नाउ इट हैज बिकम जीरो. Now we have computed, this is being done at receiver. We have computed row wise and column wise parity bit. तो पहले में हमने कंप्यूट की तो 1, ठीक है, 1 ऐड हो गया और उसको कंपेयर करेंगे जो रिसीवर के साथ जो आई है उसके साथ। यहाँ पे जो है जब आप कंपेयर करेंगे तो ये 0 रिसीव हुई है, 0 रिसीव हुई है, लेकिन एक्चुअली आपके नंबर ऑफ वंस कितने हैं, वो 3 वंस हैं, लेकिन यहाँ पे 0 रिसीव हो रहा है, लेकिन ये 3 वंस हैं। ये तो 4 वंस होने चाहिए थे, 0 होने के लिए 4 वंस होने चाहिए थे, लेकिन ये, इसका मतलब ये हुआ कि ये बिट एरर में है। अब ये कैसे पता लगा, ये उस वक्त पता लगेगा जब आप कॉलम भी लेंगे, इसकी लोकेशन उस वक्त पता लगेगी जब आप कॉलम बिट भी लेंगे। कॉलम वाइज जब आप कंप्यूट करेंगे तो ये चीज आ जाएगी। कॉलम वाइज अब आप जब कंप्यूट करेंगे इवन पैरिटी, तो ये 0 आ रही है ना, जैसे नो एरर के साथ 0 आ रही है, लेकिन इसको होना क्या चाहिए था, ये अगर ये 1 होता तो तब ये 0 होनी चाहिए थी, लेकिन ये 0 आने का मतलब ये है कि दिस बिट इज एन एरर, दिस बिट इज एन एरर, ये जो बिट है। सो इट मींस दैट two dimensional bit error has an additional feature that it not only detects error but it can also correct error. We can also correct error. Correct error means that we can find out the location of bit which is in error. So have a look on it. I'll give you 2 minutes for it because this is a little bit complex thing to understand. So I'll give you 2 minutes for it to review two-dimensional bit error parity. Okay जी, is it okay to everyone? किसी को कुछ चीज पूछनी है तो welcome. Little bit different two-dimensional. One single bit error you have already studied in logic design, but 2D error we are studying 2D bit parity. 2D bit parity we are studying for first time. So if you have any question, you are welcome. So what is the additional feature? If you don't have any question now, I will have one question. What is the additional benefit of 2D bit parity? Gee, who will tell me? Gee, anyone?
सर मतलब ये करेक्ट भी कर सकता है ना, सिंगल बिट पैरिटी आ रहा है तो सिर्फ डिटेक्ट करता है.
Right. So it can correct. So it is highlighted in blue. Maybe you are feeling shy, or I don't know what is the reason. It's very easy. It is highlighted in blue that you can see that when you take a row parity only, you cannot find out the location. But when you will take a column parity also, then you will be able to trace the location of exact bit which is in error. And once you have traced the location of bit, error correction is a piece of cake in this sense, because there are only two possibilities. So in second row, second bit is an error, so you flip this bit from 0 to 1, so it is corrected. So this is an additional thing, that 2D bit parity can also correct errors in addition to detection. Detection means simply that group of bits are in error. Detection means that simply group of bits are in error and you don't know the location of that bit. But when you say correction, you know the location of that bit. And once you know the location of bit, you can easily correct the bit by flipping it. Either if it's 0, you can flip it to 1, it will be corrected. If it's 1, you will flip it to 0. So पहले कॉलम के अंदर इस एग्जांपल में थोड़ा सा एरर है, ये 0 आएगा, यहाँ पे 0 आएगा, यहाँ पे भी 0 आएगा, ये करेक्ट कर लीजिएगा. Okay जी, so let's proceed to next slide. Now this is checksum. Second method is checksum. I will not repeat it. You already studied the checksum. So please go through this. Checksum, you have already studied it. Same checksum method is there. So first method is parity bit detection, error detection using parity bits, 1D, 2D. Second method is checksum. This is review. Just review, so I will not repeat it. Please have a look on it. फिर भी if someone has a question, they can ask. G, any question about checksum? If so, someone has any question, so they can ask. Otherwise, I'll move to next slide. So now the third method is known as cyclic redundancy check. The third method is known as cyclic redundancy check, and we abbreviate it as CRC. And if you compare this method with previous method, this is the more powerful error detection method. Again, detection method, not correction method. So it is the more powerful error detection method, coding method, in comparison to the methods you have studied earlier, checksum and 2D parity. So again, now we'll talk about the exact, method of CRC. So D, let's call a variable D, which is data bits. So basically, they are, binary numbers, obviously. And then we have a generator G. Again, that is also a bit pattern, but that are additional bits. And we are calling it as a G for generator. This is also a bit pattern, and it is of R plus 1 bits, and it is given. Generator is given and the generator is known by sender as well as receiver. Keep this thing in mind. ये r plus 1 bits का मतलब क्या है, ये मैं अभी आगे थोड़ी देर पहले बात समझाऊंगा कि r क्या है और r plus 1 bits क्या हैं. But generator has r plus 1 bits. It has one additional bits in comparison to r. r क्या है? r is a data bits with appended zeros. वो अभी मैं अब आगे जो है ना एग्जांपल में आपको क्लियर हो जाएगा. So D, we have defined D and G. So look at this, what happens. So R actually are, look at this, R bit pattern. R is a result of this computation. R is a result of this computation, which we will give you example, and then you will find it out. Okay, how R is computed, but it is computed with the help of D and G. But it is computed for simplicity, for understanding purpose. I am telling you this, that R is computed with the help of D and G. And once R is computed, that R is appended with D at the sender site. Once R is computed, R is appended with D at the sender site. Okay, so it is also a bit pattern. So D and R is computed with the help of D and G. So G is known by sender as well as receiver, and then after getting R, it is appended with D data bits. Mathematically, we can say that this operation is known as that these are R is a group of bits, and R CRC bits, number of bits, R CRC bits. So mathematically, we are multiplying this D into 2 raised power R, and we are taking it exclusive OR with this R. This is mathematical representation of this phenomena. This is a mathematical representation of this phenomena कि D और R का mathematical interpretation जो है formula for bit pattern जो है is given like this: D into 2 raised power R with exclusive OR with number of R, capital R. So what is the goal? Goal is to choose RCRC bits. RCRC bits को collectively we are calling it as capital R. RCR bits are group of bits which are calling as a capital R, such that D and R are exactly divisible by G. What is G? G is generator. So this is modulo 2 arithmetic, जहां पर रिमाइंडर जो है वो चेक किया जाता है. Modulo 2 arithmetic. So the choose, your goal is that we choose RCRC bits capital R such that your this D and R are exactly divisible by this capital G generator. So as I already told you that G is known by receiver and generator as well. G is known by receiver as well. So receiver, what it does, when receiver gets this D and R, basically it also divides GR by G. It also receiver when it gets D and R, it divides, receiver also divides it by G, because G is already known by receiver. Then it divides it D and R, which this D and R, by G. And if remainder is non-zero, if non-zero remainder is there, then we say error is detected. If remainder is non-zero, then we say error is detected. Obviously, if remainder is zero, then it means no error. But if remainder is non-zero, it means that error is detected. And it can detect all burst errors. Burst errors means more than one bit error. लेस देन आर प्लस वन बिट्स, ये आर सी बिट्स हैं, आर सी बिट्स हैं. अगर बर्स्ट एरर जो है वो उसकी नंबर ऑफ बिट्स लेस हैं आर प्लस वन बिट्स से, सो इट कैन डिटेक्ट ऑल द bit errors. And this methods of CRC is widely used in practice. It is used in Ethernet standard as well as Wi-Fi standard, 802.11 Wi-Fi standard. Please have a look on it. I have told you a lot of information in it. There is a lot of information embedded in this slide. So I'll give you again 2 minutes to review this. And if you have any question, then you can ask. Later on, we'll also take one example to demonstrate that how CRC is computed.
सर ये जो जनरेटेड बिट्स हैं, जी बिट्स,
जी,
ये रिसीवर और सेंडर दोनों डिसाइड करेंगे या सेंडर डिसाइड करके रिसीवर को इन्फॉर्म करेंगे?
नहीं ये स्टैंडर्ड के अंदर जो आपका स्टैंडर्ड IEEE का, उसमें जनरेटर के बिट्स डिफाइन है. वो फिक्स पैटर्न है एंड दैट इज ऑलरेडी डिफाइंड. जनरेटर नोज इट एज वेल एज रिसीवर नोज इट कि कितने बिट का जनरेटर यूज कर रहे हैं. ये प्रायर पता होता है दोनों को, ये डिसाइड नहीं होता. ये सिंपली स्टैंडर्ड में पता है कि जी आपने 16 बिट का जनरेटर यूज करना है और उसकी पैटर्न क्या है वो भी नोन है. दोनों को पता है एग्जैक्ट पैटर्न एज पर स्टैंडर्ड. So nothing is computed. This is known. Okay, जी.
Yes.
Okay, ji, is it okay if there anyone wants to ask any question? Welcome. Okay, if there is no question, let's proceed further. Now let's take an example. Mathematically, we are saying that d into 2 की power r exclusive r will generate ng. और equivalently हम ये भी कह सकते हैं कि ng के साथ अगर हम exclusive r को r से करें, ये इसको right side पे ले जाएं, तो they are same things. d into 2r and g exclusive r same thing. Or if we divide now equivalently, another interpretation is if we divide d into 2 की power r by g, ये g इधर आ जाए, तो we will get a remainder r. We will get a remainder r. ये उधर चला जाए ng, n number of bits हैं, extra bits. ये भी मैं बताता हूँ आपको. तो r जो है वो हम remainder r ले लेंगे. We want a remainder r जो satisfy करेगा this thing. रिमाइंडर r कैसे निकलेगा? d into 2 की power r divided by g. g is known, d is data bits and r is redundant bits. अभी मैं वो जो r की बात की थी अभी. So in order to do this, let's take example. Let's take a simple 4-bit generator. Again, this 4-bit generator is known by sender as well as receiver prior to transmission of data. Advance में पता है इनको, generator को भी receiver को. So they do not do any negotiation on it. They already know about it. So this is a generator, and generator has a 4-bit pattern 1001. And these are data bits. Now this is our data bits. And data bits are 101110. Now what we do actually is that we do, now look at this data bits. कितनी data bits की कितनी bits हैं? Count, please count the number of bits, data bits, B. So there are 6 bits. Now we will append zeros in it. We will append zeros. How many zeros? Look at this. We have appended how many zeros in data bits?
4.
Data bits कितनी थी?
6.
तो 6, तो ये टोटल बिट्स कितनी है अब?
सर 3 zeros append किए.
3 0 append की है. Now there is a rule for appending number of zeros. The number of zeros must be 1 bit less than of generator. Generator की कितने बिट्स हैं?
4.
तो हमने zeros कितने किए? 4 minus 1, 3 zeros append किए. ठीक है, 4 minus 1, 3 zeros append किए हमने. ये रूल है कि जनरेटर की जितनी बिट्स होंगी उससे एक बिट लेस zeros append करेंगे डाटा बिट्स के साथ. And now we are calling it as mathematically as d into 2 की power r. We are calling this mathematically as d into 2 power r. Okay. Now next step. We will divide this now d into 2 power r with generator. The division. Now I don't need to tell you division. डिवीजन का मतलब है कि एक्सक्लूसिव आर ले लें. माइनस करने की बजाय सिंपल चीज है कि एक्सक्लूसिव आर लेना शुरू कर दें. 1 का एक्सक्लूसिव आर 0, 1 0 का एक्सक्लूसिव आर 1, फिर आपने नेक्स्ट बिट ले ली. क्योंकि नेक्स्ट बिट ये 3 बिट्स ली थी, तो आपने मैथमेटिकली आपने यहाँ पे 0 लगाया और 3 zeros यहाँ पे लगा के आपने 4 बिट्स करनी, क्योंकि जनरेटर 4 बिट्स का है. जनरेटर 4 बिट्स का है, तो मैथमेटिकली ये कैसे होगा? पेपर पेंसिल मेथड में आप डिफरेंट तरीके से करते हैं. आप यहाँ पे सिंपली स्ट्रेट 0 ऐड कर देते हैं, ऊपर भी 0 लगा देते हैं. लेकिन कंप्यूटर में लिटिल बिट डिफरेंट कि आप 0 लगाएंगे, क्योंकि 3 बिट्स हैं, जनरेटर की बिट्स 4 हैं, तो 0 0 लगा के आप 4 बिट्स जनरेट करेंगे. नेक्स्ट जो है वो बिट एडिशनली ले लेंगे. नाउ देयर आर 4 बिट्स जनरेटर के इक्वल आ गई हैं. नाउ व्हाट यू डू? Again you will take a 1 and you will divide it with generator. Generator क्या है? 1001 है. फिर आप exclusive OR लेंगे. Exclusive OR लेंगे तो उसी तरह 101, ये तो 00 आ गए, ये 101 आ गया, ये 1 आ गया. फिर आप next bits लेते लेते you will get a remainder. This would be your remainder. Have a look on it. Please verify this. I'll give you 3-4 minutes for it. कि वेरीफाई करें कि यही रिमाइंडर आता है कि नहीं आता पेपर पेंसिल मेथड से. Please take 3-4 minutes and quickly verify this using your notebooks. When you finish your competition, please speak up. Okay, ji, is it okay to everyone? If anyone having any question, welcome. क्या आपने verify कर लिया है? जी, anyone verified it or not? Am I audible to everyone?
Yes.
जी, ये कैलकुलेशन समझ में आई है? ये रिमाइंडर किस तरह आया डिवीजन के बाद? जी, should I assume that everybody understood it? Okay, I'll assume. Now, after doing this, you will remove these 3 zeros. ये जो 3 zeros आपने append किए हैं, इनको आप remove करेंगे और उसकी जगह आप ये r remainder जो है ये सेंटर साइड पे ये जो 011 आया ये 3 zeros की जगह append कर देंगे और इसको ट्रांसमिट कर देंगे सेंडर से रिसीवर की तरफ. व्हाट यू विल डू, these थ्री जीरोस जो आपने शुरू में लगाए थे अपेंड किए थे अपने पास से उनको रिमूव करेंगे और रिमाइंडर की बिट्स को वहां पे अपेंड कर देंगे. तो ये क्या हो जाएगा 101110. पहली 6 बिट्स डाटा की थी, उसके बाद जो क्या आएगा आएगा 011. सो इट विल बिकम अ CRC. जो CRC है वो क्या है, ये जो रिमाइंडर बिट्स हैं उनको CRC बिट्स कहा जाता है. रिमाइंडर बिट्स को CRC बिट्स कहा जाता है और आप वो 3 जीरोस को रिमूव करेंगे सेंटर साइड पे और CRC की बिट्स जो कि R बिट्स हैं उनको यहाँ पे अपेंड कर देंगे और इसको ट्रांसमिट कर देंगे. और अब रिसीवर साइड पे क्या होगा, रिसीवर विल basically get this and generator is already known by receiver. तो रिसीवर जो है वो जनरेटर से इसको डिवाइड करेगा. रिसीवर जो है वो जनरेटर से इसको डिवाइड करेगा आर बिट्स को शामिल करके और अगर उसका रिमाइंडर नॉन जीरो आता है तो इट मींस देयर इज नो एरर. It means there is no error. So please do calculations. कैलकुलेशन क्या करनी है आपने, ये 011 यहाँ पे 3 जीरोस, इस 3 जीरोस को कर्सर नजर आ रहा है आपको, इन 3 जीरोस जो हमने एक्स्ट्रा जीरोस ऐड किए थे इसको रिमूव करें, इसकी जगह 011 लगाएं और दोबारा जी से डिवाइड करें और फाइंड आउट करें रिमाइंडर क्या आता है. डिड यू अंडरस्टैंड द क्वेश्चन?
Yes, sir.
Please do this. Please quickly do this. This is what you need to do.
सर मेरा रिमाइंडर तो 0 आ रहा है.
So it means that when you will get a remainder 0, it means there is no error. Now, as a home practice again, change the bits, some bits in it, change some bits in it, and then find out remainder again 0. So when you will change the bits, it means that you have introduced the error in it, and once you will introduce the error in it, then you will find out okay, you will get a non-zero remainder. But please practice this at home because we don't have much time. Today we will take a break at 2 p.m. उसकी रीजन ये है कि 2 बजे लाइट यहाँ पे जाती है तो 10 मिनट जनरेटर चलने में लगता है तो we'll take a break at 2 p.m. today. Okay, so keep this thing in mind that today there will be a break for 2 p.m. So now consider the review questions. The first review question. Consider the transmission analogy. This completes 6.2. This completes 6.2. जी कोई आंसर बताएगा? Anyone?
सर ट्रांसपोर्टेशन मोड्स जो थे आई थिंक वो लिंक लेयर के हमने एनालॉग.
Okay. Right, transportation
सर
mode.
जो हमने ट्रेन और डिफरेंट मोड्स यूज किए थे.
Right, agreed. So this is the answer. Transportation mode is the proper answer. Okay, this car, bus, train is basically related to this. Next question. So this is an interesting question.
जो ट्रांसपोर्ट फेयर है उसमें हमने ये बात भी की थी कि इन ऑर्डर डिलीवरी वो गारंटी देती है, तो सर आई थिंक वो तो बाकी लेयर्स नहीं प्रोवाइड कर पाएंगे।
Okay, ji. Let's now look at the possible answer. So each link layer guarantees कि IP datagram sent will be received rather without errors. ठीक है? लिंक गारंटीज करता है कि आपकी IP डाटाग्राम जो सेंट है ओवर लिंक will be received at the other link without errors. But it is not guaranteed datagrams will arrive at a proper order. So you are right. So this is something which is a possible answer.
सर तो रिडंडेंट नहीं हो,
Proper order में नहीं होगा, फिर with IP datagram in the same TCP connection can take different routes in the network, and as a result they will arrive out of order. Therefore TCP still is needed. So please read the answer, and if you have some supplementary questions in it, you are welcome to ask. Okay, ji, next question. What are some of the possible services that a link layer protocol can offer to network layer? Which of these services have corresponding services on IP TCP? Comparison. So there are various services which are provided. So let's have a look on it. Framing. So there is also framing in IP and TCP. Framing से मुराद ये है कि header add होता है और TCP में भी header add होता है और उसमें भी होता है. लेकिन लिंक एक्सेस एक ऐसी चीज है जो कि आपकी लिंक लेयर प्रोटोकॉल देता है. लिंक एक्सेस सिर्फ लिंक लेयर प्रोटोकॉल देता है, लेकिन फ्रेमिंग जो है आईपी और टीसीपी में भी होती है. फ्रेमिंग से यहाँ पे मुराद इट मींस के काइंड ऑफ एडिंग अ हेडर, एंड दिस इज आल्सो डन इन आईपी एंड टीसीपी. रिलायबल डिलीवरी, so that reliable delivery is also present in TCP, you know, so it is also present in link layer. Flow control, flow control is also present in TCP. Error detection, so that is also present in IP and TCP, and but error correction is not present there. So error correction is only present in link layer. Full duplex, so TCP is also full duplex. Please have a look on these answers, and if you have any further supplementary question, you can ask. Is it okay to everyone, Ji? I assume it's okay. So this completes 6.2. But one thing I would like to share before we move to 6.3 is this thing. International standard on CRC. So international standards has been defined, and they are basically defined for by IEEE mainly, and they are 8-bit, 12-bit, 16-bit, and 32-bit generators. Let me tell you that this Ethernet, this LAN standards are Ethernet is a popular standard, which is a IEEE standard. So CRC 32-bit CRC 32 is a 32-bit standard, and it is adopted in link layer IEEE protocols, variety of protocols, and this is a GRC 32-bit standard generator. ये जनरेटर है 32 बिट का जो यूज होता है प्रैक्टिकली. Look at this generator. ये bit pattern, this bit pattern is known by sender as well as receiver. This bit pattern is known by हमने तो अपने एग्जांपल में 4 बिट लिया था फॉर अंडरस्टैंडिंग, लेकिन this basically is being used by practically by 32 bit generator is used, and this is known by sender and receiver in defined in standard, and sender and receiver knows this. You don't need to transmit this to each other. So each, as I told you earlier too, each of the CRC standard can detect burst errors of fewer than R plus 1 bits. So it means that consecutive bit errors of R bits or few here will be detected. So this was the last comment on international standard on CRC. At this completes 6.2. So please have a look on it. अगर किसी को कोई question है तो welcome. कोई और तो नहीं ये आया क्लास में लेट? 110 प्रेजेंट है?
यस सर.
तो आप कितना लेट आए हैं बेटे?
सर जी मैंने पहले ज्वाइन की थी, फिर लाइट चली गई थी, अभी फिर 10-15 मिनट पहले ज्वाइन की सर जी.
ओके
सर जी लाइट नहीं आ
so
रही.
you know that software can exactly tell me that how long you have been there, but anyways, so
सर
please
जी
try to, because light is a big issue these days. So anyways, let's hope it will be resolved within 1 or 2 weeks. So anyways, I have marked your attendance, so try alternate ways ढूंढें.
ओके सर.
Okay, okay जी. Okay ji, this completes 6.2. So we'll take a break here now. We'll take a break here now. Before and after break, we'll start 6.3. And 6.3 is basically multiple access protocol. It is a quite lengthy topic, and probably will not finish it today. But anyways, we'll start 6.3 after break. And let's take a 15 minutes break, and those who want to pray, they can pray. So okay, so let's take a break now. Okay ji, break starts from now. $15 break, please note the time. Okay जी, can you listen to me? आवाज आ रही है आप सब लोगों को?
Yes, sir.
Okay, light has come back. So there was a certain delay due to load shedding. So now let's start. Let me share the slides and then we'll going to start. Okay ji, can you see the slides? Slide number 21.
Yes, sir.
Let's start 6.3, which is multiple access protocols. So, uh, you know, before we talk about multiple access protocols, let's talk about two types of links. One link is known as point-to-point link, and the other link is known as broadcast link, which is a shared wire or medium link. Point-to-point link means that there is a direct point-to-point link between Ethernet switch and host, or even there is one protocol for dial-up access. Now, dial-up is not used, but again, direct line from host to router or something like that. That is known as single line, and no other person is sharing that link. So that is known as point-to-point link. The other type of link, which is known as broadcast link, in which a wire is shared or medium is shared between multiple hosts. So the examples of that are old-fashioned Ethernet. Old-fashioned Ethernet because current Ethernet do not use this. But look at this left side diagram. Cursor, my cursor. This computer basically is using a shared medium. यहाँ पे देखिए common bus है और उसके जरिए 5 computers जो आपस में connect हो रहे हैं. This is not used in now current Ethernet but shared wide medium. Here we need it's a broadcast. This is a shared radio. The medium is shared between all these devices. This is a shared radio Wi-Fi. Here 4G, 5G, here Wi-Fi, here satellite. So it means that when you are sharing the medium, then there are additional issues, which we'll talk about it very soon, that two or more nodes can start communicating with each other. Two or more nodes can start sending data at the same time. When they start sending data at same time, then that data, that frame will collide and there will be a no success of transmission unless and until you have some kind of algorithm or protocol. So analogy is given a party. In party there are many people are there, and if they start talking at the same time, so nobody will understand who is talking to whom. So this is something which will occur. So therefore, we need some kind of protocol in case of broadcast medium. Therefore, we need some kind of protocol in broadcast medium. Have a look on it. If you have any question, welcome. I assume it's okay. You have understood what is broadcast. So in broadcast, what happens? Broadcast channel, which you have seen examples in last slide, that basically there is a single channel. For example, a wireless channel is a single channel, air is a single channel, and that is shared between many nodes. That is shared between nodes, and as a result, there is possibility that two or more nodes they start simultaneous transmission. As a result, there will be interference. And when there will be interference, then there is a collision. We call this when simultaneous transmission occurs and these frames collide with each other. There is a certain term, standard term, which is used, and that is known as collision. Collision means that two or more signals of nodes are transmitted at same time and one or more bits collide with each other. And we say that collision has occurred. We say that collision has occurred. Okay, Ji, we say this is a standard term that collision has occurred. So, in order, what is the solution to avoid this kind of scenario? So, the solution is to devise some kind of protocols, and collectively, these protocols are known as multiple access protocols. We call them as there are various types of multiple access protocols, but collectively, we call them as multiple access protocols, which basically devise certain rules and regulations to have a successful transmission in shared broadcast channel. So basically it's an algorithm, distributed algorithm, which basically determines how to share nodes in a shared channel, how to transmit in a shared channel. Basically it determines when node can transmit, when a certain node can transmit. Basically it determines when a certain node can transmit, right? So this communication between about channel sharing must be channel itself. So there is no out of bound channel for coordination. Within that channel, coordination will be occurring. There will be no separate channel for coordination. So this is something introduction of multiple access protocols. That these are the protocols which allows the successful communication of nodes in a shared broadcast channel. Please have a look on it, read it, and if you have any question, you are welcome.
सर ये लास्ट पॉइंट नहीं समझ आया.
Sorry, last point means के देखें, you know, in a wired medium, basically we can have wired medium की example दूंगा कि आप जो है ना different आप पेयर्स रख सकते हैं, कोऑर्डिनेशन के लिए सेपरेट पेयर रख सकते हैं, ट्रांसमिशन और रिसीविंग के लिए सेपरेट पेयर रख सकते हैं, एक सेपरेट चैनल रख सकते हैं, वायरलेस में भी एक सेपरेट चैनल रख सकते हैं कि जिसमें आपका कोऑर्डिनेशन हो, आपस में नोड्स की आपस में कोऑर्डिनेशन हो. बेसिकली कोऑर्डिनेशन तो होनी है क्योंकि आपके दो से ज्यादा नोड्स सेम टाइप पे ट्रांसमिट करेंगे तो कोलिजन हो जाएगा. सो इस कोलिजन को अवॉइड करने के लिए देयर मस्ट बी कोऑर्डिनेशन बिटवीन दोज नोड्स. अब वो जो कोऑर्डिनेशन के लिए कोई सेपरेट चैनल मौजूद नहीं है, वो वही चैनल है, सेम चैनल है जो जिसके में ट्रांसमिशन हो रही है, उसी चैनल के अंदर ही कोऑर्डिनेशन होगी. दिस इज व्हाट डज इट मींस by no out of bound channel. Okay, there is no separate channel for coordination. Same channel which is used for transmission of packets will be used for coordination. Is it okay, Ji?
Yes, sir.
Okay. So let's proceed further. So now we'll start with the ideal protocol, multiple access protocol, and then we will be dropping the ideal conditions gradually to arrive at the real protocol, like we have done in chapter 3 when we were studying, the reliable principles of reliable data transfer. So same thing will happen in this case, that we'll start with the ideal multiple access protocol, and because this is Mac layer पे काम करता है, तो people sometimes call it as multiple access channel protocol. Medium access control भी इसकी abbreviation है और multiple access channel protocol भी है. So let's say that we have a Mac in this case is multiple access channel of rate, data rate उसका क्या है, उसकी bandwidth क्या है, r bits per second है. Now this is given that we have a channel, multiple access channel क्या है, multiple access channel से मुराद क्या है, वो shared channel है, right? Having characteristics which we discussed in last slide. Now what is decider? Now what is this? Algorithm steps for this. When one node wants to transmit, it can transmit at a rate, maximum capacity of that channel, that is R. It can transmit at R. But when M nodes wants to transmit, each can send at average rate of R by M. So this is second thing, that if M nodes wants to transmit, that bandwidth will be divided, that rate will be divided R by M. And this is fully decentralized. Step 3 is this is fully decentralized. Decentralized means that there is no special node which is coordinating between for transmissions. There is no special node for coordination of transmissions. There is no synchronization of clocks or slots. And this is simple. So this is a ideal access protocol. Practically speaking, it is not possible to achieve all these 4 points, 3 points in fact. But again, we are starting with the ideal thing, right? Please have a look on it. If you have any question, you are welcome. Okay, now let's proceed next. Now, there are 3 broad classes in MAC protocols, multiple access channel protocols, right? There are 3 broad classes in it. The first class is known as category classes, whatever you say, channel partitioning, that we divide the channel into smaller pieces like time slots, like frequency, like code, and allocate piece of node for exclusive use. कि वो जब टाइम स्लॉट्स या फ्रीक्वेंसी या किसी कोड में डिवाइड कर देते हैं, तो क्या करते हैं, फिर हर पीस को हम हर नोड को एलोकेट कर देते हैं एक्सक्लूसिव यूज के लिए. ये वो उसका वो टाइम स्लॉट होता है और उसमें वही नोड ट्रांसमिट कर सकता है. दिस इज व्हाट वी कॉल channel partitioning. Second class comes in random access class. We call it as random access class. In random access class, channel is not divided. So when channel is not divided, collisions will be there. So the collision is a natural process. If because you are not in random access, channel is not divided into time slots, frequency, or code. So naturally, collisions will be there, and it's a natural thing which will occur in random access. So the method is the algorithm recovers algorithm described in random access class basically recovers describe a method to recover from collisions. So this is the second class. The third class is known as let's call it as taking turns class. This is not a standard name. This is a name given by author. The first one and the second class is a standard name, channel partitioning and random access. Taking turn is a name given by author. That's why it is written in inverted commas. So it means that nodes they take turns, but nodes with more to send data can take longer turns. So we will talk about these three methods one by one. Have a look on it. If you have any question, you are welcome. Okay, Ji. Is it okay to everyone? Am I audible to everyone, Ji?
Yes, sir.
Okay, now let's move to further detail of these three broad classes. So the first one is known as channel partitioning MAC protocols. I think you have already studied a communication system course. पढ़ा है सब लोगों ने communication system course?
Yes, sir.
Basically उसमें आपने TDM भी पढ़ी होगी, FDM भी पढ़ी होगी, ऐसे ही है? जी, am I right? टाइम डिवीजन मल्टीप्लेक्सिंग पढ़ी है आपने?
सर TDM तो पढ़ी थी, सॉरी FTM पढ़ी थी, TDM का आई डोंट थिंक तो पढ़ी.
Anyways, so I'll explain it to you. TDM is that basically बहरहाल आपको पढ़नी चाहिए थी या बहरहाल anyways will not go into this debate. So let's move to that where it is. So basically the time this time during multiple access, the channel is divided into time slots. Channel is divided into time slots and access to channel is given in rounds. For example, each station each station or node gets a fixed length slot, and that length means that packet transmission time in each round, that each channel will get a fixed range of time to transmit a packet. Now if there is nothing to send for a node or station, then that slot goes idle. That slots cannot be used by some other station. For example, if you look at this, there let's say that we have 6 station LAN, And in first six station lines means that we have divided the total time into 6 equal time slots, and each slot is given to each station. Now look at this first scenario. Here station 1 is given a slot and it has something to send by represented by blue color packet. So this is being sent by this station 1 in its own slot. The next slot is reserved for station 2. Station 2 has nothing to send. So that slot remains idle, vacant. Then next slot is given to station 3, red. So red slot is given to station 3. Station 3 sends its data. And then next slot goes to green station 4, and station 4 also sends data. But station 5 slot and station 6 slot is idle, vacant, because it is because they have nothing to send. And the problem, the issue with this TDMA is this, that these idle slots cannot be given to other stations. If they have more data to send, they cannot be given. And then after doing this, it will repeat. Again, station 1 slot will come, then 2, 3, 4, 5, 6, and so on. Look at the next thing. Next 6 time slot maybe each is more or less scenario repeat हुआ. Station 2 और 4, 5, 6 को फिर कोई data send करने के लिए नहीं है, तो वो slots idle है. So this is something a disadvantage of TDMA, that if certain node or station don't have anything to send, that slot remains idle or that slot remains wasted. So this is what we call TDMA. Have a look on it. Okay, ji, is it okay to everyone? किसी को क्वेश्चन हो तो प्लीज गो अहेड. If someone has any question, please ask. If no, let's move to the next one, which is FDMA. We call this as FDMA. So let's move to FDMA. So FDMA is another channel partitioning protocol, and instead of dividing the channel into time slots, FDMA divides the channel into frequency slots. FDMA divides the channel into frequency slots. Means that channel spectrum is divided into various frequency bands. and each frequency band is assigned to a station. Fixed frequency band is assigned to each station. Same case is here, that if certain node has nothing to send, that frequency bands remains idle. So look at the figure, और इस figure को देख के try to understand. You have already studied FDM, so please look at it और इसको जरा समझें. Is it okay to everyone जी? किसी को क्वेश्चन है तो प्लीज वेलकम. The last method is known as CDMA, code division multiple access. In this, CDMA assigns a different code to each node, and each node then uses that unique code to encode the data bits it sends. This unique code is sometimes known as chip. Each node is assigned a chip, different code, and that chip is used, or data code is used to encode the data it sends. So if codes are carefully selected, then CDM has wonderful properties that you can different nodes can transmit simultaneously, and yet their respective receivers can receive the data encoded bits using that code without interference. And it has a lot of use in military systems due to its anti-jamming properties and widespread civilian use, particularly in cellular telephony. So this is a third method, and we'll stop here because this completes this category, the first category, channel partitioning protocols. And please have a look on it, read it, and if light goes, automatically class will terminate. If light goes, automatically class will terminate. But anyways, please read this, and if you have any question regarding it, you are welcome. Next is multiple access, random access protocols. We will study that, inshallah next time. Is it okay to everyone, Ji? Am I audible to everyone, जी? सबको आवाज आ रही है?
Yes, sir.
Okay, then by this we close today's class. So at the end, if you have any question, you are welcome to ask. Otherwise, that's all for today.